Okay, can you turn on your camera, please? So today we'll continue the lesson about Boolean algebra. Okay. Boolean algebra. Okay, so last meeting, okay, I briefly introduced about what is Boolean logic or Boolean algebra, right? So basically, Boolean algebra is a study of compound proposition, okay, where the logical expression are analog to arithmetic expression in ordinary arithmetic. So it's the same as logic, but the difference is only true become 1, false become 0, okay, and become multiplication, or become addition, not become negative. Okay, so these are the symbol in Boolean logic. So true, false. Okay. Remember, and in here we make it the same as multiplication. Okay, not is the same as negative, so we can also make it on the top or accent. Okay. Those are the things that make it different between logic and Boolean algebra. And these are the basic law in Boolean algebra. We will discuss more detail later. So the things that make it different is this. So 1 plus 1, meaning true plus true, is still true, right? What is the meaning 1 plus 1? 1 plus 1 is true or true. Of course, it's true. Right? So subtraction is actually this 0 minus 1. What is the meaning in logic? 0 is false, okay? Minus is not, right? 1 is true. So false, yeah, this one is plus, meaning this is the same as plus or minus 1, right? Oh, I already put that. So 0 minus 1, that means 0 plus minus 1, right? 0 itself is false, plus mean or, minus 1 mean not true, okay? So in that case you have false or false, and of course false. Okay? So multiplication mean m, okay? So if you want to compute faster, you can use this guide. Okay? If your value x is a value, if your value is actually larger than 1, to make it 1. Okay? If your value is less than 0, negative, so make it 0. Otherwise, itself. Okay? Either 0 or 1. Okay, so now the compound based on the truth table, okay, is the same as logic. Okay? So in here we have the logical compound of n. You see in the n, okay, so when it will become true, yeah, P and Q will become true if and only if, yeah, both P and Q are true. Okay. The same thing, now P multiplied by Q will become 1 if and only if, okay, P and Q are 1. Okay. And this is the symbol. Look at this symbol. Okay, this is the symbol of and. So you can easily see this is that is okay, kind of intersection but very close. Okay, next symbol is or. So this is the symbol of or. Okay. Or will happen to become false even only if both argument, okay, P and Q are false. Okay, so this is the one that you need to memorize. Okay, that the truth table of or is always like this. Okay, so because false represents 0, then you will have exactly the same. Okay, so we have P plus Q will become 0 if and only if P and Q are both 0. Okay, and how about not? Not is the same thing as negative. Okay? So you can put it as minus P. Okay. Okay. So negative of 1 is 0, negative of 0 is 1. And this is the symbol. Why we want to introduce the symbol? Because using the symbol, now you can create something, a network of logic. Yeah? Using Boolean logic, you can create a network of logic. This is very interesting. Yeah? So look at this example here. So can you write down the function that represents this logic here? What is this symbol? X1 and X2. What is this symbol? Anyone can? Yeah. X1 and X2. What is the symbol there? You go up in the slide before. Anyone knows? What is the symbol there? X1 and X2.
And
And, yeah, this is and. Okay. How about this one? X3 and X4. What is that symbol?
and, sir.
And
Same.
also. Oh, okay, very good. And also, huh? How about this one? What is this symbol? Check the slide. Okay, that is not. Okay. How about this symbol? What is this symbol?
Or.
Or, very good. Now, can you create a function based on this network? Can you create a function based on that network? So what you will do is you will put n, right? What is the the input of n, the first one? That is x1 and then x2, right? That is the top part here. And then you have n again. What is that, the bottom part there? X3 and x4, right? And then what you will do there, the output of that n, the second n here, x3 and x4, you put it into not, right? So you put not here. Huh? So you close it. And then you put it into, what is that? Or, right? So that means what you will do with that. That means you will do or in here, okay? And then you will close this comma and then close one more. Is it clear? Ah, okay. If it is clear, now I have x1, x2, x3, x4. Okay, you open your Excel. Okay. And then I have several questions here. What will be the output if the input is this? Okay, so what will be the output? Okay, let me put this into numbers so that I can assign. Okay, so number 1, who will answer? Number 2, who will answer? Number 3, 4, and 5. So I have need 5 students to volunteer here to answer this question. Okay, what will be the output? So what you will do with that? So using Boolean algebra, you can create a circuit. Yeah? You can create a logic of circuit. Okay. So let me put it out. So screen Excel, right? So what do we have here? What do we have here? We have x1, right? We have small, yeah? x1, x2, make it the same like this. x2, x3, x4. So this is the input. Okay. So for example, okay, number 1. What is number 1? 1, 1, 0, 0, right? And then I need to get the y. The y is what? How do you get the output of the y? And here you put OR, right? Okay, I will put this. This one is called x1. Okay, x underscore 1. This one is x underscore 2, right? This one is x underscore 3. And this one is x underscore 4. Okay, so I need to calculate the y here. How do you get the y? So you get OR, right? OR of what? I get the n of x1, comma x2, right? And then you get the not, right? And then what? You get the n of x3, comma x4, huh? So this is the close of the n, this is the close of the OR, huh? So this is the answer. Okay, so if you want to binarize, so if it is true, then 1, otherwise 0. Okay, so there the answer is 1. So this is the answer. So in the circuit, okay, in electronic circuit, 1 mean have voltage, right? 0 mean no voltage. Okay, so using this, you can create any circuit. Okay, electronic circuit. So logic is the same. Okay, you can create a algorithm in computer and so on using and or and not. Similar to this kind of way. Okay, so who can answer number 2?
Sir, could you show us the formula again?
The formula. Okay.
The two and one on your Excel.
This one.
Oh, yes, sir.
My question to you, do you know how to get this formula?
No.
No, okay. But you know the meaning of this drawing, right?
Yes, yes.
Yes. So this is n, right? So you see, okay, I will do it one by one, okay? So the first n, what you will do? You will put n, right? N of what? X1 and x2. Is that so? That's the first part, right? And then second part you will put n again of what? Of x3 and x4. Is that correct? Okay. So that is, after that, this one you put not, right? So not of what? Of the second part. Right? After that, what you will do, you put or. Or of what? Or of or, okay, of this not and this and. Yeah. Is it clear? Or is it confusing? So once you can get that, I just combine it together all in one. Right? This is exactly the same as step by step a while ago. Okay, but now I put it all in one formula. Okay. It's the same, right? So you can create a Boolean function with any input. So in this case, the how many input? 4 input. Right? So this is more powerful than the usual logic that you experienced before, right? Because now you can put any input. Okay? You can put 10 input, and then you can have many output also, not just one. Okay? And then you can draw. So very powerful.
Sir, I want to ask for
The second,
1100. Do we have to put the formula x_1, x_2?
uh,
Do we have to?
which one? Which one?
Uh, the one under the x1.
This one.
Yep.
This one is the name. You
Oh,
know,
oh, oh. Okay, okay,
okay?
okay.
This is the name. So I just keep name so that you can easily tell that this is actually the
Oh,
name.
okay, okay, okay.
Okay?
I thought it's a must. Okay.
No, it's just a name so that you can easily, otherwise you will get B4, C4, isn't it? So then you don't know what is C4, B4. So now I just make it into the same name as what is in the slide, isn't it? Hmm? Oh, okay. So what will happen if you have a 1000?
True, sir.
Hmm? So 1000, still true. Okay. How about the third one? Of all 000,
True also, isn't it?
still true. Yeah. How about if we have 1111?
True
One, one,
also.
one, one. Oh, still true. How about the last one?
True also.
0110. Oh, true also. Wow. So then you may wonder, is it really tautology? Right? So you may wonder, is it really tautology? No, we don't know. So if you want to know it is tautology or not, then what you will do? You will try all the possible values, right? So how do you make this all possible values? Can you make all possible values? So x1. So how many, my question, how many all possible values here? How many variables? 4 variables, right? So how many all possible values in this case? For example, okay, I will put this one. 1, 1, 1, 1. And then I put 0, 0, 0, 0. Is it okay? Then this is x1. How about this one? In x2, what is the possible variation? So I will put 1, 1, 0, 0, 1, 1, 0, 0, right? How about this one? This one is 1, 0, 1, 0, oops, right? 1 again, 0 again, 1 again, 0 again. Oh, but x4 still need more. Oh, okay. In that case, what I will do, I will move this. I will move this here. That means this is all 1, right? Okay. And then after that, what will I do? I copy this everything. Okay. Here down. And then this one is all 0. Okay, so this is all possible values, right? So now you can get the y here. Okay, so how do you get the y? The same, okay? So you make it OR, right? Of the n, but the n is x1 and x2 now, right? And then what is this? Not of the n, okay, x3 and x4, right? So you close it, you close one more. Okay, so I will put this one. If true, become 1, otherwise 0. Huh? There. So and then I copy everything here. Oh, it's not tautology, right? Right? So this is all possible values. Okay, how many possible values? So 1, you will see, plus 1, huh? So you will see we have 16, right? We have 16 possible values. Why 16? Because we have 4 variables. Okay. How about if I have only 3 variables? How many? You have 8, right? If you have, so let's see, yeah. If I have 4 variables, this is number of num variable, okay, and then this is the possible value. Yeah? So if I have 4 variables, I have 16. If I have 3 variables, then I will remove the x1, so that means I have only 8, right? So if I have 2 variables, how many I will have? 4, right? If I have 1 variable, I have only 2 possible values. Okay. So can you see the pattern here? How about if I have n variable? If I have n variable,
n square.
So if 1 become 2, if 2 become 4, if 3 become 8, if 4 become 16.
2 square n.
2
2 square
exponent, yeah,
n.
2 exponent n, right? Okay. So these are all the possible values. Huh? Okay, so until here, is it clear? Is there any question? Sia, are you okay with it or not?
Oh, yes, yes, sir.
Okay, no problem, huh? Okay, last time, did we try this last week? No? You can try if you don't. Okay. So now we have two variables. So in that case, if you have two variables, how many possible value? 4. Okay. So you go here, you create a new one. Okay. So let's name it A and B, right? So then what is the possible value? 1, 1, 0, 0. In B, you have 1, 0, 1, 0, right? So then we are asked to tell the y. The y in here equal to A accent plus B. What is that?
Not A.
Yeah, not A. Okay, not of A. Okay, and then
And B.
Plus. What is plus?
Or.
Or. Okay, the plus mean or. Okay, or P, right? Or P. Okay, so you got that. Okay, so of course you can put it into integer again. If true, then 1, otherwise 0. Yeah? So, oh, you got that. Okay, is it easy or difficult? Boolean algebra is actually simpler than normal logic. Okay, this is much simpler. Okay, so yeah, 2 doda n. Yeah, this is the number of Boolean function of degree n is 2 exponent of 2 to the n. Yeah, so now this is example of Boolean function, isn't it? This is again example of Boolean function, right? Okay, so now if you have only one variable, okay, if you have only one variable, what is the Boolean function of one variable? What is the Boolean function of one variable? One variable. So you can, if you have only one variable, you need unary operation, right? So in unary operation in Boolean function or in logic, what is the unary operation? So if you use AND, that is binary operation, you need at least 2 input, correct? You said OR, that is binary operation, you need at least 2 input, okay? So what is the next one? That is only unary operation.
Not.
Not, very good, okay? So not is require only one input, that is unary operation, okay? That means if you have only one, okay, Boolean algebra, Boolean variable, okay, so you can only have an not or itself, right? So in that case, we can say, okay, these are the all possible function, okay, of Boolean variables. What are they? Okay, say variable. Okay, let's make it into Excel again. Huh? So your x is only one x, right? So what is the possible value? Either 1 or 0, correct? Right? So then let's make it into F1. So it say in the slide, okay, if you have only one Boolean variable, you have 4 functions. So then you need to find out what are they, right? What are they? What function that actually create this value? What are the possible values? Of course, easy, right? So you can put it 1, 1, 0, 0, right? And then 1, 0, 1, 0. So I just make it like that, right? So these are all possible values. There is no other possibility, right? Right. So, but remember, this is the input, right? This is the input, and this one is the output. So I will color it column here. Yeah, the output is this one. Oh, sorry, I will make it different color so that you know that this is actually different function. Okay, let's make it different function. What color? Okay, I will. Where is there is no red? Okay, I like pink, so let's color it pink. Okay, so what is this F1? What is this F2? What is this F3? Okay, you imagine like this. I have y is a function of x, right? And this is the y. Okay, the y is, I call this F1. Oh, okay. If my x is 1, my output is 1. If my x is 0, my output still 1. Oops, what is that? What is that function? Okay, so that function is called tautology function. Why? Because whatever input you put, okay, it always give you 1, right? So this is called tautology, right? Why? Because whatever input, it doesn't care about your input. It's just care about the output, which is always 1. That is tautology, right? Remember, tautology means all 1. Remember? Okay. Oh, in that case, if this is tautology, I know this one. What is this? Whatever your input, it's always 0. It's always false. Okay, tautology means whatever your input x doesn't matter. It's always true, right? That's tautology. But now I have whatever your input x, now it's always 0. What is that function name? We have discussed many times before. You forget? So that is called contradiction. Okay. Okay, so this is called contradiction. Why? Because if I have 1, okay, if my argument, the first argument is true, your result still false. If I'm false, your result still false. Whatever I'm doing, I'm always false. That's being contradiction. Okay. So whatever the input here, okay, always false. That means contradiction. Oh, in that case, what is F2? What is F2 in this case? If x is 1, F2 is 1. If x is 0, F2 is also 0. So, this is just mimic the input, isn't it? Imitation, right? So, this is called, this function is called projection. Okay. Why? This is project the input. Right? Oh, the last one, what is this? If x is 1, if the input is 1, the output is 0. If the input is 0, the output is 1. Oh, what is that? Anyone knows?
Negation.
Yes, negation, right? It's the same as not, isn't it? Right, so this is negation, yeah? So up to here, we have 4 functions with 1 Boolean variable. Is it clear or not? So with that, of course, you can extend, okay? How about if I have 2 Boolean variables instead of 1? Okay. What is the meaning? I have x1 and x2. Right? So what are the values? The value can be 1, 1, 0, 0, and here is 1, 0, 1, 0, isn't it? Right? So these are the all possible values, right? Then, how many functions that we can create, okay, using two Boolean variables? How many functions we can create, okay? So if you read the slide, it's 2 exponent to the 2 exponent n. N is in here 2, right? So in that case, what? 2 exponent 4. Okay, so exponent 4 is 16. So you will have F1, F2 until until F16. Yeah. Okay. So now if you go to the slide, okay, I don't want to do it in here. So if you go to the slide, we have listed that. Yeah, we have listed that. Okay. So this is the input. Okay, in this case, two input, right? X and Y. In this case is the input. Okay. The output is F1, F2 until F16. Okay. So clearly F1 is the same as earlier. Whatever your input, it doesn't matter. It always 1. So in that case, what is F1? Tautology, isn't it? The same thing with F16 here. Okay. This is always 0. Yeah, whatever your input is, okay, it always produce output of 0. In that case, this is contradiction. Yeah. So then all the others you can check. Okay, what is the meaning? So remember you have and earlier, right? For example, and or. You remember function and. Oh, this is not right. This is or. Or you see here, if I have if I have 1, 1, 0, 0 and 1, 0, 1, 0, the result is 1, 1, 1, 0. This is the pattern of or, isn't it? Right? So if you look at the table, 16 table here, so where is the pattern of or? Okay, the pattern of or is in F2, right? Right? Why? Because you look at the input. The input is 1, 1, 0, 0, and then 1, 0, 1, 0, exact. Okay, and F2 will produce the pattern of OR. Right? So F8 in here will produce the pattern of AND. And so on. So these are the 16 Boolean function of degree 2. What's the meaning of degree 2? Two variables. So up to here, is it clear na? Last week you make comment that, oh, I don't understand because all 1 and 0. This is very funny comment. So I hope now you understand. Okay. Tell me what you understand and tell me what you don't understand. It's okay. I want to get your feedback. Hilly, what you understand, what you don't understand.
I understand how many possible values when we have x variable, like for one variable, how many possible values that we can have, we will have.
And then,
Yeah. And
so do you know what is the meaning of this one? Oh, F10, for example, in here.
F10.
Hmm. What is that?
Exclusive OR.
Yeah, why this is exclusive OR?
Because
How do you look at it and then say that this is exclusive OR? How do you say that? How dare you? Huh? How dare you say this is exclusive OR? So prove it that this is exclusive OR. F10. Anyone can help? Billy?
I don't know why.
You don't know why, okay.
If one and zero, the result always one. I don't know why.
What is the meaning of exclusive OR?
There will be only one thing that will happen. For example, 1 or 2, there will be only 1 or 2. It could not be both. It
Uh-huh.
could not be 1 and 2. That's what I understand.
So it's the true OR actually, right? Without both. Okay, so now if you have x1 and x2, okay, x1 is true, x2 is true also. So what is the exclusive OR answer? True and true become
False.
become false. You see that? In F10 you check.
Wait,
Right?
why is it false?
I thought not both. You just said a while ago. Or exclusive OR is the same as OR but not both. Right? If both, that is false.
Oh, okay.
Yeah,
Okay, I get it. I get it.
Yeah. So exclusive OR is the same as or in one either one, right? But not both. Okay. So that's why if both are true, it become false. Okay. So the middle part is clear, right? Always true because this is OR, right? So 0 and 1, 1 and 0 is always true. But and then the later part is also clear, right? If both are false, of course false, right? So what do you think? Give me feedback, Felicia.
I understand about writing the formula like a binary one, but I a little bit not understand about with the diagram.
Which the diagram now? You don't understand. Maybe we need to practice more. Unfortunately, I did not make it. Okay. So the diagram, okay, is the same as, oh, I think I have one more. But before that, wait. Let me show I have, this is the diagram of exclusive OR. Okay, this is the diagram of exclusive OR. So the diagram is standard. You can check in Wikipedia or in Google. Okay, this is the standard diagram international, meaning this is the circuit diagram that any electronic book usually will have the same diagram. Okay, unfortunately, you need to memorize. Right. So, how about the diagram of this one? This is also the diagram of NOR and NAND. You see that the dot there. If you have only this part, this is N, right? But now you put this dot there, now become not. Okay. If you have only like this, okay, this is OR, right? But you put circle there, now become not. Okay. So later on, okay, you will practice, for example, where is that part? Oh, there, for example, like this. So you know, what is this? Do you want to practice this? So what is this? This is n, right? This is also n. This is not. Okay. Right? What is this? This is or, right? This is or. This is not. This is not. Oh, what is this? This is not n. Right? This is or. Right? And what is this? This is no, not or. Not or. Okay, so you need to memorize that. And then you just input it. You once you have this one, you can create the function. Okay, anyone can create the function. We'll get recitation point today of this. How many input and how many output? Of course, two output. Y1 and Y2. The input is only 4. Okay, X1 until X4. Oh.
What is this?
That is jumper. So meaning you jump. That means you don't go there. It jump. Okay. So from the end of X3 and X4, you go directly to NOR. Okay. Anyone who can make this? When you practice, then you can see. Oh, quite complex, yeah. So next week we will have quiz on this, on Boolean algebra. So how are you going to do this? Again, the same, okay? So I will create so you have x1, x2, x3, x4. Okay, let me save. I will create new Excel. Okay, you try first. Okay. Once you finish, you tell me. Okay. So x1, x2, x3, x4. So I will just put any value. 1100, for example. So what you will do, so from x1 and x2 you create n, right? So you put n of x1 and x2, and then from x3 and x4 you create another n, right? Okay, so I will share my Excel. Okay, so from here, okay, I give a name of x1, x2, x3, x4. This is my input, right? So I just put any value. Say I just input value 1100. Okay, so let's make the drawing. Okay, so first we have x1 and x2, right? This one. And then the next one you have another n, right? N of what? X3 and x4. Right. Okay. So this is done. Next, what you will do?
Not.
No, not. Okay. That you create a knot, right? So one is you create a knot equal to knot of the second one, right? Okay. And then on the top, what you will create there?
Nor.
NOR. Okay, so I have NOR. NOR of what? NOR of the output of this one and
The bottom
the
one.
output of the earlier. Okay, which is just x3 and x4, right? Okay. So I create a NOR. And then down here you have, what is that? That is OR. Okay, that is OR. So you have OR of what? OR of the
First one.
not the first one, and then up. Okay, this one, right? Is that correct?
Yep.
Oops. I need to close it. I create that OR here. Okay. After that, what you will do? From that OR, I will create in here SOR, isn't it? Huh? This is SOR. SOR of what? SOR of this one.
Nor and or.
Yeah, the NOR and the OR. Okay, so this one is become y1. Okay, so this is equal to y1. How about down there? Down there, you need to create NOT.
Not.
Okay, NOT of what? NOT of that. NOT of this OR. Is that correct? Yeah, this is the OR, correct. And then after you create that, you need to create what is this? The last part. It is the y2. That is
Not. Not n.
not none. Okay, none. That one, right? Not n. Okay, so that one is I can create none. None of what? None of this one and the output of that OR. Is that correct? This is the OR. Correct. So this is the y2, right? This is the output of y2. So I have this, and now I just copy, huh? Just y1 and then y2 in here. I just copy this. Okay. So, oh wait. I will just copy. I will put if this one is true, then 1, otherwise 0. Right? Same thing here. If this one is true, then 1, otherwise 0. Right? So this is the output. Okay, so you created that. So then you just change the value of the input. So What do you think? Is it difficult or not?
At first, but
After you try, you know how to do, right? It's not
yeah.
difficult. You just need to trace the line, okay, the arrow. And you need to know the symbol, of course, right? Okay, so now you can have, you see, this is no longer a function, right? Actually, this is relation, isn't it? Why? Because now you have many input and you have many output. Okay, what's the difference between function and relation? Okay, in function you have many input, only one output, right? But if it is a relation, okay, you have one or many input, you have many output. Okay. So this is much more powerful than the function because now you can have many output. Interesting actually, isn't it? Now you can create what logic you want. And then you can draw it. Remember, one means you have voltage. Yeah, you put the battery on it, okay, and then you put the on, okay. One means on, right? Okay. You switch it as on, okay. Zero means off, no electricity. So, okay, practically your computer, radio, television, every electronic device is basically based on this Boolean logic, isn't it? On and off only. Correct? Okay, so that's why this is important. Even though it look like, oh, only 0 and 1. Yes, it's only 0 and 1. Okay, but this is the basic of everything that is electronics. Correct? Okay. So the real physical things is 0 mean off. Okay, no voltage. Okay? 1 mean on, have voltage. So that's why computer can do things, logic, okay, can display something because of computer is basically doing Boolean logic, right? Okay, that's why you can program it later. So I hope you understand the importance of this. Then that can at least motivate you a little bit. Okay, to overcome your burden of 0 and 1. So what do you think? Is there any question? Is this still complicated? Tamara, how's your competition?
Oh, what competition?
I thought you did not join last time
Oh,
because of competition.
committee. I was not a participant.
Oh,
Yeah, it was great.
okay. That's good. Okay, so let's continue back. Okay, where is that? Now I want you to understand, okay, several common operators in logic or Boolean algebra. Okay, so we already encountered a while ago, right? None mean not and, okay? Nor mean not or, okay? SOR is the same as or, but when both of them are true, okay, they are not true, become false, okay? And then of course we have implication and equivalence. Yes, please.
For nor and none, in the Excel, we put nor.
Oh, because I have my own program there in the back. But if you don't, you just put not and, not or. It's the same thing.
Oh, okay.
Okay. Remember last week I show you I created my own here, right? You can also create your own if you want. You just copy this. There, nor is just like this. Can you see? There. Nor, this one. And none. None is just not and P and Q. Okay? Nor is just not or P or Q. Not, okay? You see? You just create a macro behind the Excel. Oh, maybe next time or next year you will study Excel anyway, right? You will create that. When you finish IBE, you will become superpower. Yeah, you will know business, you will know programming, you will know mathematics, you will know engineering. Wow. Okay. Yeah, the curriculum is really very nice actually in IBE. Okay, so where are we? The diagram a while ago, is it okay already or you're still confused?
It is okay.
Joycelyn, how is it?
I tried it, but I haven't finished.
Oh, okay. Just take time then. Okay, let's come back here. Okay, these are the most common operator. Out of that 16, okay, these are the most common operator. Okay, so the projection, okay, and what is this? Second negation, first negation, non-implication we did not include, right? So these are the most common operator aside from and, or, and not. Okay. So okay. So this is SOR, okay, exclusive OR. Okay. Look at the pattern here. If both are true, okay, so of course the result is false. Why? Because the meaning of SOR is or but not both. Now, how if I want to create SOR, okay, from and, not, and, or, and not, the three Boolean function that we usually use. Okay, then this is the formula. Okay, this is the formula. So what is this? This means not A and B, or not B and A. Okay, so let's try this in Excel. We'll create a new function. Okay, let us see here. Okay, I will copy this. I'll put it here. Okay, so I have A and B, right? I'm supposed to have SOR, okay? But I want to get SOR not directly but indirectly using this formula. Okay, so I will have not A and B, right? And then I will have not B and A, right? And then I will have both. Okay, so this is supposed to be the SOR 2. Okay, I will put it SOR 2. Let's check if that is true or not. Okay, so what we have two variables, right? So okay, you want in Boolean or you want in true false? Yeah, let me do it in Boolean. So 1 1 0 0. So here is 1 0 1 0, isn't it? So the SOR is easy. You have the formula already, right? So the SOR of this one comma this one, right? So okay. So if you want to make it Boolean, you just put if 1 otherwise 0. Okay. So how about this one? Not A and B, right? Not A and B. So you will put not. What is not? Not of the A, okay? And then and B. So you put and here. And of the with B. Okay. How about this one? This one is not B, right? Not B, this one. So then you put N of not B and what? And A. Okay. And then this one plus mean or, right? So you put or of this one, comma this one. So I just copy this, I put it down. Oh, I got that value. Okay. Oh, exactly the same, isn't it? False, true, true, false. Eh? So if you don't like true, false, you can put it if. Eh? Then 1, otherwise 0. Okay, the same thing here. You can put if 1, 0, right? The same thing here. I can put if 1, 0. Okay. So now I have proved that this is actually SOR. Eh? The left hand side is the same as the right hand side. Okay, when the truth table, okay, we have the same pattern for the same input, the same pattern of output for the same input, then they are equivalent. So what do you think? So most programming language have SOR, okay? But suppose you don't have SOR, then you can create. In the slide, I just put the same proof. Okay? How about implication? So how if I want to create if then, but only using and or not? Can I do that? Yes, you can. Okay. So if P then Q is equivalent to not P or Q. Maybe I'll just wait for you first. Are you working still in the network a while ago?
still working on the the many thing, the many diagram.
Oh, the diagram. Okay. I'll just mute that. Oh, there. Oh, you get, everyone get 100 except Matthew. For the Matthew, what happened?
I make a mistake, one mistake, sir.
Yeah, Google is unforgiving. If you make one mistake, it becomes 0. So you need to test its answer. Okay? Okay, good.
So I want to ask if it's
Yeah, cool. What what do you want to ask?
if it's if it's correct. This
What is this? Are you working
the
at? Oh, the long
the long diagram thing.
long diagram. Do I have it? Oh, here it is. Okay, so the long diagram. Oh, what is your input? Your input is 1 1 0 0. Now become 1 1. Yeah, correct. And then if you have 1 0 0 0, you got 0 1. Yes. And then if you have all zeros, you get 0 1 also. And then if you have all 1, you get 1 1. Yes. And then if you have 0 1 1 0, you get 0 1. Okay, very good. Very good.
Thank you, sir.
Yes. Okay. Everyone can do it. Okay. So now you can say to your friend in electronic, okay, electrical engineering. Oh, I can do circuit also, you said. Okay. You can just say like that. Oh, I can do circuit also. Okay. Of course, you did not we did not learn deeper. Okay, we just learn the logic. Okay? We did not learn the Kirchhoff diagram. Probably you did learn that in high school, right? Kirchhoff, ampere, ohm law. I don't know. I did learn that in high school before, and my high school was only public high school, so that's supposed to be standard. Okay. Anyway, So let's do the implication. Okay, let's do the implication. So I will share my Excel. I will create a new Excel sheet. Okay, let's name it implication. Right, so let's name this P and Q. Right. So then I will have if P, then Q. Okay, so if P then Q. Last time we already have that. Okay, you can use if then, but this time we want to use and or and or and not. Only that. So actually P, P, if P then Q, that is equivalent to what? Equivalent to not P plus Q. Okay. Let's check that is true or not. Okay. So what is P in here? You have 1, 1, 0, 0, right? As usual. So now I have 1, 0, 1, 0. Right? So let's test it. Okay, let's test that. What is this? So if P then Q, otherwise true, right? Last time we do like this, right? Okay, so and then we add again because so we add again this 1, 1, 0. Now, okay, this is the pattern of if then. Okay, now we want to prove that this is actually the same as not P or Q. Okay, so we'll put or here. Or of what? Not, right? Not P. And then Q. Okay, let's check. Oh, yes, that's correct, right? So if you want to make it binary, you can just put like this 1, 0. Exactly the same. Huh? Is there any question here? Oh, I can also make it another way. Okay, this is the same as P. The same as P equal P dot Q. Is it? Okay, let's prove it if it is true or not. Okay, so how to do that? You would just say if P equal N of P and Q. Right? Then 1, otherwise 0. Huh? No. P equal P and Q. That is correct. P3. That is not true. No, that is not true. So this is not true. No, this is not true. So the one in the slide is not correct. Okay, I will check again. Why this is not correct. Okay. So I put correction. Okay. This is A equal, is A equal to A times B? Oh, this is not correct. Anyway, so this is correct, right? Okay, now let's do contrapositive. So, if A, then B, that is called implication, right? Now, when we said if not B, then not A, that is called contrapositive. So, if not B, then not A. Okay. So, if you look at it, okay, contrapositive is actually have the same truth value as implication. Okay, contrapositive have the same truth value as implication. So when you said if A then B, that is equivalent to say if not B then not A. Okay, why? Because when you put it into the truth table, okay, this is exactly the same. Okay, so until here, is there any question? How about equivalent? How do you say that A equivalent to B? Okay, so equivalent means identical. I will always say if and only if. Okay, that means equivalent. These are the symbol of equivalent. Okay, 3 equals, okay, or 2 arrows. Okay, 2 arrows like this. So this one, if you want to combine, okay, equivalent mean A and B or not A and not B. Okay, and this is the pattern of equivalent. Okay. You see here, this is exactly the reverse of what? If you look at this pattern, this is exactly the inverse or not of what?
SOR.
SOR. Very good. Wow. Yeah, this is the same as SOR, but not SOR. So equivalent is basically not SOR. Okay. Good. So be careful. Okay. Equivalent means biconditional. So it has the requirement that both, yeah, the condition and consequence must be both true or both false, but we don't care which one. Okay, this one is equivalent is equal to not SOR. Okay, so okay, we have also nor and none a while ago that we discussed. Okay. In set theory, you remember the Morgan law. You remember or not? Set theory.
Things will always go wrong.
That Murphy's law.
Oh.
Murphy's law.
Okay.
The Morgan law. Okay, type in Google the Morgan. I'm sure you learned this in high school. I'm sure. The Morgan law. No? Yes. Jocelyn said yes. Right? Matthew, you did not learn the Morgan law before?
I don't know, sir. I think not.
Okay, anyway, no problem then. So I will, those who have learned this, so I will just refresh, okay, review again. Okay, those who did not, so I will just tell in here.
So can I see the Excel form before the P then Q, not P plus Q?
The Excel of if P then Q, is that the one?
Yes, yes.
Mm-hmm. Uh, which part you want to know? Is this the one? Okay, so let's go to the, are you okay, Kenneth? Can I move on? This one is just if, the usual, if P then Q. Okay, so let's move on the Boolean logic on duality. So the duality of Boolean expression is obtained by interchanging the multiplication with plus and interchanging the 0 and 1. This is based on what is called the Morgan law. Okay, so there is a primal and dual. Okay, so the dual of this equation here. Okay, so you look at it this way. If this is x, okay, then you make it x accent, right? If it is multiply, you make it plus. Okay, when you put it plus, you make it into multiply. When it is positive, you make it into negative. When it is 1, you make it into 0. That is the dual. Okay, again, now this is the, can you find the dual of this, right? So the x in here, this is already negative, right? X accent, that means you put it into x. And then you have plus in here, then you put it into multiplication, right? And then the y here is positive, so make it negative. In here you have plus, then you make it into multiply. The z here is negative, then you put it into positive. Is it clear? Okay, practice, okay? Who can do the dual of this? Oh, there is no answer, okay. I need 4 volunteer. Can you find the dual of number 1, number 2, number 3, number 4? If you can answer this, you can claim your presentation point. Come on.
So what is dual? I missed it.
Which one you will do?
I ask what is dual?
Oh,
I
the
missed.
dual. The
I
dual
missed
is the exchange. Here, this is the what is dual. The dual of the Boolean expression, okay, is obtained by exchanging the multiplication with plus and interchanging of 0 with 1. That is the dual. The dual means
What is accent? And for accent?
accent. Accent mean not.
No.
Sir, I want to do it, sir. Number 1, sir.
Number 1, okay. Matthew is number 1, okay. Oh, Kenneth, you are number 2. Who is not confident? You can try so that I can help you also. Oh, who want to do number 3? Felicia, number 3. Okay. Number 4, who will do number 4?
Me.
Okay, number 4, Billy. Okay, try. You can answer it here.
Just annotate, sir.
Yeah, just annotate. Okay. So, number 2, the x is positive, then you need to make it negative. That means you need to put not. Okay. Okay, correct. Minus x. So, plus 0 minus mean what? That is already negative, right? That is plus, that mean multiply after that. Huh? Number 2 is not correct. Number 1, x, you need accent, plus, what is this? X accent multiply, and then this is accent, yeah? The y have accent, correct. Number 3, x accent plus y accent plus z accent. Very good. Okay. Number 4, x accent multiply by y. The y accent. Okay, that's okay. Okay. So number 2 is still not correct.
If it's minus, then what do I do?
So remember, minus mean plus with minus. That means you multiply with the x only.
Oh, sir, for number 4, do I need to change
Oh, you
YZ
can, you can expand that.
YZ to, is it supposed to be Y plus Z?
Y accent plus z accent.
Accent, okay.
Right? That is equal. You can put again. Yeah? You can put it. No, that is already correct. But you can expand.
Oh, is YZ correct?
YZ accent, that is correct. A while ago, that was
Oh.
already correct. But you can expand it. That equal again. Okay. Why we talk about the dual? Because the truth table of the dual is exactly the same as the primal. Okay. Multiply. Put parentheses. Don't forget to put parentheses. Huh? Plus. Y accent plus, but you need to put the parentheses still the same. The parentheses does not change. Yes. Okay. So now you try the truth value. Okay. Of these, you input in Excel. Okay. You know the truth value is either 0 and 1. So if you have 3 variables, you have 8 possible values, right? Then you can try, okay, the primal and the dual, are they the same or not? Okay, it must be the same. If not the same, is incorrect. Okay, so the dual is important. Why? Because they have the same truth table as the primal. Okay, so let's clean up the annotation. I will clear all the drawings. Okay, so this is the rule of Boolean algebra. Okay, of course you don't need to memorize, but if you memorize, you will get advantage. Okay, the one that we just discussed a while ago, this is called the Morgan law, which is this one. That is the dual that we just discussed a while ago. Okay. Okay. Now look at it one by one. Commutative law. You see the first part, the first row there. A times B equal to B times A. Commutative, right? You can exchange the order. A plus B, that is OR. Remember, N is multiply, OR mean plus. Okay? So A plus B equal to B plus A. Okay? How about associative law? Okay? You can have associative law for addition and for multiplication. Okay? The same with distributive law. Okay? I think all of these are the same as usual arithmetic rule, right? Except the one that I put there in the red. So be careful with this. Okay? Only in Boolean algebra we have this rule, but in normal arithmetic you don't have this rule. The one in red here. Okay, the one I put in arrow. Okay, so A plus B times C, you can put it out. Okay, A plus B multiplied by A plus C. Okay, in the usual number, in algebra you cannot do this. Okay, but in Boolean algebra you can do this. Identity law. Identity law is what? A plus 0 is A times 1 is A. Okay. Idempotent, A plus A, back to A times A, again back to A. Huh? Dominance law, A times 1 equal 1, A times 0 equal 0. Okay? So complement law, what? Okay, these are the, if you have A plus A accent, that equal 1. If you multiply, that's equal 0. Okay, of course, 1 accent is 0, 0 accent is 1, right? So if you have double accent, A accent, that equal back to A. So double complement is come back to A. Why we talk about this, right? Because using this one, now you can prove without truth table. Now you can prove without truth table. How to do that? Using algebra only. Now you can prove it. Okay. How to prove? To prove is to use this algebra, okay, to find tautology. The same as before. Okay. So this is example. Okay. Using Boolean algebra rule, prove that the contrapositive, okay, is true. Okay, so then I will look at this value. Okay, so this is just copy, right? This is just copy of that. This is just copy. So this is line, let's put it line 1, line 2, line 3, line 4, line 5, line 6. Okay, line 1 is just copy. Line 2, what is this line 2? What rule we use to create from line 1 to line 2? This one is distributive law, right? This part. And then the right hand side here is the definition of implication. Okay, from line 1 to line 2, I use distributive law and definition of implication. From line 2 to line 3, what do you use? Why A accent plus A multiplied by A is 0? Which rule is that?
Complement, sir.
A accent times A accent times A, complement law. Okay, very good. So Next, from line 3 to line 4, 0 plus something. Okay, 0 plus something, you can remove the 0. Which law is that?
Identity, right?
Huh? 0 plus A equal A, right? That one. So identity law. Okay. And then now from line 4 to line 5.
Morgan.
If then, that is the definition of if then. Right? The same as here in the second. This is the definition of if then, right? And then from line 5 to line 6, yeah, this is just simple. A plus A is A, right? Okay. B plus B accent is A plus A is what? A plus A is A. Okay, and then B plus B accent, so that is the same as A plus A accent here. Complement law become 1, right? So then you have A plus 1. How about A plus 1? A plus 1, by dominant law, you become 1. So finally, we reach the conclusion that all of these are tautology. 1. So if you can prove that this is tautology, this is the same as truth table. You don't need to create a truth table, right? So now you can use algebra, the rule of algebra. Then you can create the proof. Wow, amazing. This is now you have another way, right? Before you only use truth table, always put 0 and 1 or true and false. This time you don't need, right? You only use algebra and then you derive. Oh, you can get tautology. Or you cannot get tautology. If you get 0, that means contradiction. Okay. How about this one? Can you use Boolean algebra? Okay. Is this form valid or not valid? Practice. Okay, this is not valid. But can you prove it that this is not valid using algebra only without truth table? Anyone can do? You can write here. If P then Q, what is that? That means, yes. How about to put it into and or not? If P then Q. Yeah, but you need to put it into Boolean algebra. Come on. If P then Q, a while ago what we will use?
Plus.
Plus, yeah. If not here, P implies A, that means not B plus A. The same in here now. Okay. If P then Q, that means not P, not P. Not, you just put a bar on the top of P. Okay. And Q. Okay, and then and, what is the meaning of and? And is you put that all together, okay, and then multiply by Q. Okay, and then does P, what does that mean? Implies again, right? Implies. Implies first. No. Otherwise you need to put accent all. No. No. The accent is in the first part, not the second part. One. Okay, very good. Now you need to play with Boolean algebra now to make it into either tautology or contradiction, or you cannot solve it. Come on. So you have, can you do distributive after this, right? Can you do distributive? Or you want to do De Morgan first? That's also okay. O plus, Q times Q is Q, okay, and then so now you have accent for that. Then you can use the Morgan law, right? Okay. Every time you have accent of a parenthesis, then you can use the Morgan law. The Morgan means the dual. Can you find the dual? Then if that is plus, now become multiply, not okay. There is something wrong. This is multiply, so you need to make it plus, right? Q multiply by not P. If you take the dual, will become not Q plus P, right? Then you put the parenthesis, yeah, plus there, and then one more parenthesis out. Okay, very good. And then what you will do, why that is 1? Which one make it 1? Q accent multiplied by Q accent, still Q accent, right? Plus P times Q accent, still P times Q accent. Okay. And then plus P. Okay. So which rule you will use? Wow. So you need to check which rule you will use. Okay. So how is it? Which rule you will use? This is my answer. Okay. Finally, you will get the Q accent plus P, okay, which is not 1, right? So then this is not valid. Okay. Okay, so this is, you cannot make it tautology. Okay. Whatever you do, it cannot become tautology. So in that case, you cannot say that this is valid form. Okay. Okay, so with this, I hope you can practice more, okay, on the others, okay. So okay, until here. So should I give you assignment? Should I give you assignment to prove this one? Is it okay to give you assignment? Yeah. So minimum literal I will not discuss. Okay, this is so until 51. Okay, I will not give you assignment, but this is part of the quiz next week. It's the same, right? So if you don't do it, so you may not be able to solve it. Okay. So you practice on your own. Okay. So at the beginning of the class next week, we will have a quiz on Boolean algebra only. Okay. Until page
The practice
51.
is the 52.
Yeah. Until page 51. Okay. So from 52 onward, you don't need. Okay. So long time ago, I tried this, and then I was able to find this formula. This is the formula you can check in Wikipedia. This is the formula that I created. This is also based on Boolean algebra, and now it bear my name. So this is for image processing, for computer vision. Using this formula, you can actually clear the background of the image, okay? Or you can create the background of the image. Okay. Okay. So with this, I can say that our lesson on Boolean algebra is finished. Okay. So that's why we have quiz next week on Boolean algebra. Okay. So next week we discuss again the propositional calculus. So please read before the class. Okay. So see you. Thank you.